Hey everyone, and welcome. Today we're diving into a concept that, well, it quietly powers a ton of the apps you use every single day. Component-based architecture. We're going to explore how modern software gets built, not as one giant single thing, but block by reusable block. So let me just start by asking a question. How do you build something complex, like an app or a website, that you know is going to have to change all the time? How do you keep adding features, handling more users, and fixing bugs, all without the whole system just, falling apart? This is the exact problem that component-based architecture, or CBA, is designed to solve. All right, so here's our game plan for this explainer. We'll kick things off with the basics of what CBA even is. Then we'll jump into its biggest advantages and dissect what actually makes a component, well, a component. From there, we'll get practical with an implementation guide, put it head-to-head with the old-school monolithic approach, and wrap up with a few challenges you gotta watch out for. So what exactly is component-based architecture? To really get it, we're not even gonna start with code. We actually have to look at something a bit more physical, like a factory assembly line. At its heart, CBA just means that software isn't built as one single massive piece of code. Instead, it's assembled from all these smaller, independent parts we call components. The best analogy really is that modern assembly line. You don't build a car from a pile of raw metal in one go, right? No, you assemble it from pre-built parts. An engine, a transmission, a steering system. Each part is its own self-contained unit, and they all connect together through standard plugs and bolts. That's the exact same idea behind CBA. Now, this idea has actually been around for a while. It first popped up back in the 1990s. The theory was solid, but honestly, the technology just wasn't quite there yet. Fast forward to today, and this architecture is everywhere. So what changed? Why is it blowing up now? Well, in a word, the cloud. Technologies like Docker and Kubernetes have created the perfect environment for these independent components to be built, deployed, and scaled way more efficiently than ever before. Okay, so we get the what, but now for the why. Why is this so popular? I mean, why go through all the trouble of breaking everything down into these tiny little blocks? What's the actual payoff here? This quote just hits the nail on the head. It really does turn software development into something that feels a lot more like building with Legos. You've got this collection of standard blocks, and you can add new ones, swap them out, or just rearrange them to build whatever you need, all without having to smash the entire thing to make one little change. And that agility, it's an absolute game changer. The benefits here are just huge. Reusability is a big one. You build a user login system once, and boom, you can just drop it into dozens of different applications. But scalability is where it really, really shines. Imagine an e-commerce site on Black Friday. Instead of trying to power up the entire website, which is crazy expensive, you can just pour resources into the specific components getting hammered, like the shopping cart and the payment services. It's so much smarter and way more cost-effective. So we keep talking about these components, but what technically is one? Let's break down the 3 core principles that really make them work. First up, we've got encapsulation. The best way to think about this is like a little black box. For instance, a payment component handles all the messy, complex logic of talking to banks and processing transactions inside the box. The rest of the application doesn't need to know and doesn't want to know how it works. It just needs to know how to ask it to process a payment. This keeps things neat and way easier to manage. Next up is interoperability. Now, this is where the real magic happens. It's what allows all these different boxes to work together, even if they're built with totally different technologies. It's kind of like a universal remote. It doesn't care if it's talking to a Sony TV or a Bose soundbar, because it's using a standard language. Same idea here. A component written in Python can talk seamlessly to one written in Java, as long as they both agree on the interface. And finally, there's composability. This brings us right back to that Lego set. It's the ability to assemble your application by just mixing and matching different components. A perfect example is a data dashboard. You can compose it by grabbing a chart component, a graph component, and a data table component, and then arrange them all together to create a totally unique view, all while each piece stays completely independent. Okay, that's enough theory. Let's get practical. If you actually wanted to build a system using this approach, how would you do it? Here's a high-level 6-step blueprint that's pretty standard. The process here is really methodical. You start with the big picture. What are we trying to build? Then you slice it up into logical components, a user service, a product catalog, a payment processor. Now, the most critical step here is number 3, designing the interfaces, or the APIs. This is the contract that defines exactly how these pieces are going to talk to each other. Once that's locked in,
Different teams can go off and build and test their own components in total isolation before it all gets put together. It's a constant cycle of building, testing, and monitoring.
To really appreciate the power of CBA, it helps to compare it to the traditional way of building software, the monolith. This is truly a tale of two very, very different architectures. I mean, the contrast here is just stark. A monolith is, well, it's one giant unified codebase where everything is tangled together. But the real kicker is deployment. If you want to change one small feature in a monolith, you often have to redeploy the entire application. With CBA, you just update and redeploy that one single component. That small difference has a massive impact, making development faster, way less risky, and so much more flexible. And we see this in action with huge companies all the time. Take PayPal. They use reusable components to create a consistent look and feel across all their different products. By doing this, they can build and launch new features much, much faster. Or think about the mind-boggling scale of Walmart's e-commerce operations. CBA is absolutely essential for them. It helps them manage all that complexity, make sure the user interface is uniform, and dramatically cuts down on the amount of duplicated code their teams have to write. And Spotify uses this approach to standardize its front-end development. This lets them push out UI updates quickly and consistently across all your devices. Plus, it makes it so much easier for new developers to join the team, since they only have to learn about the specific little components they're assigned to work on. But look, it's not all sunshine and Legos. This approach is not a silver bullet. Shifting to this component-based world introduces its own set of challenges, and it's really important to be aware of them. While CBA simplifies the code within each component, it can make the overall system more complex. All of a sudden, you're managing dozens of tiny services instead of one big one. This can also add a performance hit. A network call between two components is just always going to be slower than a simple function call inside one application. Now, these are definitely solvable problems, but they require some really careful planning and good monitoring tools. And that really brings us to our final thought. Component-based architecture offers incredible power and flexibility, there's no doubt about it. But it's a trade-off. You're often exchanging code complexity for architectural complexity. So as our digital systems become ever more interconnected and complex, is breaking them down into smaller pieces always the right answer? That's the central question that every software architect has to grapple with.
Thanks for watching.